So what I'm going to be summarizing here in the next 20 minutes or so is basically 4 years worth of research that Cameron did for his PhD, and I think it was a very, very successful program. We looked at a lot of different variables dealing with control and the response of different ecosystems to different control strategies. And I think if you look at the just what's happened in the last year, looking at the rainfall we had in August and the droughts we had the years before that, it's pretty evident that when you're dealing with those kind of environmental variations, passive restoration is going to be a pretty difficult process to get underway. And when you look at things, a lot of the work that Cameron did was on the Arkansas River, and that's a very complex ecosystem with lots of different demands for on the land, things like grazing. Certainly, if a land manager is interested in grazing, then tamarisk is not going to be one of their major species they're interested in, except perhaps during calving season when tamarisk thickets may provide some protection. We've had severe droughts. Most of the 2 of the years, 4 years that Cameron was doing this project, we had probably half the normal amount of precip. And then, of course, last year we had a 1 in 1,000 year rainfall event, for those of you who know anything about the flooding here in Colorado that we had in August. What we're talking about really is the potential of those different ecosystems to respond to different disturbances. Obviously, if you had tamarisk that's been established for a number of years and then you go in with a very intense disturbance like a mechanical control strategy or aerial applications of herbicides, those kind of things, what you're hoping is that once that disturbance is over, the ecosystem has the resilience or the potential to proceed in a direction that's more desirable. And as you can see from this particular slide here, we have in the lower corner along the Arkansas River where Cameron did quite a bit of his research work. Russian knapweed has certainly taken over down there with the drought situation. So the last thing we want to do is go into a situation where we have tamarisk, we do a large-scale disturbance, and then instead of getting some native grass establishment and native shrubs, we wind up with Russian knapweed instead. So what we're trying to do is figure out what causes that that dichotomy there, and what situations would we get a fairly decent natural ecosystem, or at least some native plant establishment, as opposed to the establishment of more invasive species. So the objectives of Cameron's research were pretty straightforward. This is probably one of the first times that anybody had done side-by-side comparisons of a range of management strategies and then looked at the response of the different ecosystems. So what we had were a series of treatments, chemical control, mechanical, we did biological, and then, as it always works out when you start on one of these projects, we subdivided some of the bigger plots to look at individual plant treatments, whether you're doing individual plant removal or hydroaxing. You're going to have regrowth, so what should you do to treat that regrowth? So it became fairly complex, but I think Cameron did a great job of summarizing most of the research results. These are the study sites. We had 4 locations for this particular part of his dissertation. 2 above Pueblo, which would be considered the upper Arkansas, and 2 below Pueblo. The Florence site is within sight of the Supermax prison, so give you some sort of reference. The lower part of the Arkansas River is a very complex system, and it's hard to find areas where you can really do a lot of management work. The site at Ordway was really on the banks of Lake Meredith, which is a large reservoir, storage reservoir near Ordway. And that was probably my favorite site because it was very flat, very easy to get to, and we had lots of good cooperation from our collaborators. So that was one of my favorite locations. When you get to La Junta and places on the floodplain where flood management is more important to some people than restoration, it sets up a whole different set of problems that you have to deal with. So what did Cameron look at in this particular project? We looked at the standard aerial applications of the herbicide imazapyr, often known as Habitat. That's sort of the standard that we went with, that many people across the U.S. have used. This was done by helicopter, fairly high application or volume of application to avoid any off-target movement. We also looked at hydroaxing, essentially just coming in with a large machine that would mow down the tamarisk. Then we also looked at individual plant removal using backhoes. And then, as I mentioned before, inside those treatments, we also did a number of subplots where we looked at controlling the tamarisk regrowth with a number of different options. And up in the corner there, you can see we had we had the release and pretty successful establishment of the Diorhabda. We used Habitat applied on an individual plant basis and also basal bark treatments of triclopyr. We kind of thought these would kind of cover the bases of all the standard treatments that people are currently using. All right, so probably what was one of the most striking and in some ways disappointing aspects of this project for me, being primarily a weed scientist who likes to control things with chemicals, that's always my first choice, my own bias, was that if you look on as strictly how much weed control or how much tamarisk you get per dollar, it's pretty hard to compete with using a helicopter and applying imazapyr. The price of imazapyr comes down when you have access to a site where the helicopter can park very close. You're probably looking at costs less than $200 an acre to make an application of that nature. Now, what you realize after crawling around in these tamarisk thickets is that all that standing material is really of no use to anybody, and you probably need to include mechanical control of that standing biomass, even if it's dead. So a system, an ecosystem, or one where you want to have some recreational or scenic value, having all this standing dead tamarisk is not really a good option. So when you include the cost of mechanical removal of that standing dead tamarisk after you do a helicopter application, you really bring the cost down to one that's pretty similar with these other treatments. All right, so if you just want to go out and say, how much does it cost to kill one tamarisk tree with a helicopter, that's something that's very cost effective. However, when you look at the long-term impacts, and Cameron did a great job of looking at herbicide residues and their impacts on native species, and then you throw in the other component, which is you really need to control that above ground biomass to have anything that's very useful. Now all of a sudden they all look pretty much the same as far as costs. Now, I was talking about what was my most disappointing aspect of this research. How many of you know what species this is? If you don't, anybody not know? Okay, this is Kosha. And unfortunately, about 80% of all the Kosha here in Colorado is resistant to the herbicide imazapyr. And so in many of these areas where we did large-scale aerial applications, we have had very high-density stands of Kosha which have remained intact and basically impenetrable for almost 5 years now. So rather than the herbicide residue, decreasing over time and allowing native species to become established, because that's what we had seen in some of our research plots, we really just have run into a system where controlling the tamarisk allowed the establishment of this herbicide-resistant Kosha. And unlike many of you who are ecologists probably say, well, this is an early successional species, and after a certain period of time, it'll die out, and you'll have no problems with the tamarisk with the Kosha after a while. But now after 5 years, we still have densities of Kosha that are so intense that the Kosha is limiting its own growth. Right? The densities are upwards of, say, 100 to 150 plants per quarter meter square. All right? And at those densities, the plants are competing with themselves. And so rather than getting really large plants like this, what you get are a bunch of plants that are about 18 inches tall. So if anybody asks me what my biggest disappointment of this whole research project was, it was the fact that our most cost-effective treatment, at least on paper, probably resulted in the worst outcome, which is the establishment and the maintenance of these very dense stands of Kosha. All right, so here's looking at some of the other treatment measures. So if you do something like hydroaxing, you're going to wind up with a lot of tamarisk regrowth, which is shown up here. If you do individual plant removals, you wind up with a lot less tamarisk surviving if you remove the crown. We learned a lot about when to do the individual plant removal treatments. If you do them when the ground is frozen, you'll break the crown off, and you won't extract it very efficiently from the soil, and you get quite a bit more regrowth from the crown. But if you combine those treatments, the mechanical either mowing or the mechanical removal with some follow-up treatments, individual plant treatments using either habitat or triclopyr, then you're going to get very, very good control of the tamarisk, probably reducing the above-ground biomass by 95%. So, and again, when you throw the need to remove that biomass in there, there really isn't a very strong difference between aerial herbicide applications and these much more intensive treatments that require large-scale equipment. So if you look at cost effectiveness, this is essentially looking at the amount of control you get. What is this, service? Thank you very much. If you look at the amount of control that you get per dollar invested, what you find is that actually the combinations of mechanical treatments with the Diorhabda biocontrol agent provided cost effectiveness that was very close to any of the other treatments that we did. So if you happen to be in an area, and what we found, at least this is, now Dan Bean is here, and I'm sure he's, Dan, I see him, will probably, or if he didn't speak yesterday, will probably speak today. The Diorhabda, in our experience, really tends to prefer the young regrowth as opposed to old decadent plants. So you actually attract them by having lots of young regrowth for them to feed on. So in these areas where we had done the hydroaxing and we didn't treat individual plants, did I get to start on time? Okay, all right. I got the 2-minute sign already. All right. So anyway, I don't want everybody to get off schedule, so I'll try to speed up here. Okay. So that's a little bit about control. What about the plant community response? Well, as you might imagine, imazapyr, which is controlling almost all the species except for the herbicide-resistant Kosha, provides us with the least amount of species diversity. Now, what Cameron did that was very interesting that I hadn't seen many other people do, what we're basing the potential of that community on is actually taking soil samples, growing them up in the greenhouse, and determining the number of species that are present in the soil seed bank. And so that's the tall bar you see on the side of each one. That's what's in the plant diversity that we should see based on what's in the soil seed bank. What you can see is that of all the mechanical treatments, whether we combine them with other follow-up treatments, we had very much better species diversity than when we did the aerial applications of imazapyr. It's kind of a no-brainer, but at least in this case we have some numbers to say, hey, let's look at the species diversity based on the management strategy we use to remove the tamarisk. All right, another little view of community response. This is just looking at positive and negative responses, and what you see from these data is pretty clearly that even when we did the mechanical removal and followed up with individual plant treatments that included herbicides, we had a much stronger negative impact on species diversity. If we allowed the Diorhabda to come in and take care of that regrowth, we had either a very small negative impact or even a positive impact on species diversity. All right, so what about the role of rainfall in our semi-arid environment, this is a little tangential to what I've been talking about, but probably one of the best illustrations of the impacts of rainfall. This is actually from a different project in which we were looking at control of Russian knapweed, and just showing you two treatments, different areas of the state, one getting a normal rainfall of a year worth of rainfall, and one under severe drought conditions. And what you can see is that the site here, well, you can also tell that this is a much more productive site just from looking at the size of the Russian knapweed. That's very, very healthy Russian knapweed. But simply controlling the Russian knapweed gave us a pretty good stand of sand dropseed, alkali saccatone, a couple other native species came in without any seeding events. Whereas along the Arkansas River in Ordway, where we had a severe drought, controlling the Russian knapweed essentially resulted in no establishment of any native species, even though in this site we had done active restoration. We had come in with a no-till grain seeder, no-till drill, and seeded in native species. So we had very little establishment. So the point being that when you have these these tremendous variations in precipitation that we've seen the last several years, the response that you're going to get from your management strategies could vary dramatically. So it's very hard to put a number on it and say that if you follow this prescription, this will be the result, because precipitation, timely precipitation, has a tremendous impact on how the ecosystem responds. This is just one of the sites that Cameron worked on, and you can see there's been a lot of tamarisk removal. And slowly but surely, the plant there and the grass species in the front that you're seeing is inland saltgrass, a very important native species that would be very desirable in most of these cases to have inland saltgrass come in after you do large-scale tamarisk removal. Just wanted to acknowledge some people who helped with this research. Here's a picture of Cameron. We had support, obviously. Cameron is on an assistantship with CSU. We had some help from the Park Service and from the Colorado Water Conservation Board to help pay for some of the research. Cameron also wanted me to acknowledge some of his supporters, people who helped him in the field. Janet Harden, who looks like she just got off a motorcycle, but actually after getting poked in the eye a few times with tamarisk twigs, she decided to wear eye protection. And James Fowler was one of the guys that really helped Cameron quite a bit in his early work. So if you have any interest in contacting Cameron, he is on Twitter, which I have no idea. I guess that's Dr. Cam Douglas at whatever there. That's his hashtag, whatever you call it. So do I have time for one question? Okay. Any questions?
How geographically widespread is the herbicide-resistant Kosha?
It's very widespread in Colorado. I can't speak specifically to other states. Kansas probably has quite a bit, Nebraska. Further west, I don't know about Utah that much, but it is very widespread. It's a trait, a gene that's transferred in the pollen. So that's why it's so widespread, and it carries no fitness penalty to the weed. So there's really nothing to drive it out of the population once it gets established. It's extremely widespread here in Colorado. Probably 80% of all the Kosha you'll see growing along the side of the road or anywhere else is resistant to this particular mode of action, herbicide mode of action. Yes, both sides of the state, the question was. Now, on the west slope, you have probably more issues with Russian thistle than Kosha. So if you looked at the Continental Divide on the east slope, we're probably dealing with quite a bit more Kosha than Russian thistle, but over on the west slope, Russian thistle might be a little bit more prominent. And Russian thistle doesn't tend to have quite the level of resistance that Kosha does.